Guys, you need to be in section 3.5, which is on page 61. You need to go ahead and turn there, and I want you to go ahead and start with the launch. I want you to try to complete the table for these three and these three, and then I want you to see if you can find at least one pattern. I know it says to describe three here, but I just want you to find one. So I want you to go ahead and pause until you are done with that part and ready to move on to the next part. All right, so picking up now that hopefully you did this one by yourself, you at least filled out the next three blanks. And the next blank here, if I have 2 to the first power, that is going to be 2. Okay, and then you might not have known 2 to the 0 power. So let's go ahead and go over to this one and say 10 to the first power, which would be 10. Okay, then what I would do if this were me and I wasn't sure what 2 to the 0 power is, either I could go ahead and try it in my calculator and see what I get, which would be fine, or I can go ahead and look for any patterns that I see in the table to try to help me figure out those next two. So if I look at 32 to 16, I'm like, okay, if I look at 16 to 8, and then 8 to 4 and 4 to 2, I want to think about what's happening between each of those sets of numbers. And especially when I see these smaller ones, 8 to 4 to 2, I say, oh, I'm pretty sure they're dividing by 2. And so 32 divided by 2 is 16, 16 divided by 2 is 8, 8 divided by 2 is 4. So I can see that all the way down, this is divided by 2. Okay, so then when I get to this number right here, I say, okay, if I take 2 and I divide it by 2, 2 divided by 2 is 1 whole. And I talked to you guys about that throughout this chapter, that if I have 2 over 2, that gives me 1 whole. Okay, so now let me see what pattern I see over on this side. If I look at this one, and I know this is 10, probably the one that sticks out to me the most would be this one. And if I divide 100 by 10, I get 10. So let me check the other ones. If I divide 100,000 divided by 10, do I get 10,000? Yes. If I take 10,000 and I divide it by 10, I get 1,000. 1,000 divided by 10 is 100. So then I say, okay, well, what's 10 to the 0 power? Okay, 10 divided by 10. So again, this idea of 10 over 10, which is 1 whole. So then I see this pattern develop here and say, okay, well, I wonder if that's going to become a rule when I look at this today. All right, then I want to do the next one. So if I take 1 and I divide it by 2, 1 over 2. Okay, and I see this idea of a negative exponent here. It's going to give me a fraction. Okay, now I'm going to come over here and I'm going to do 1 divided by 10 because that was the rule over here. So 1 divided by 10 would be 1/10. And again, I'm seeing that I have a negative number here and that I end up with a fraction. So really important things for us to notice today. All right, we're going to go ahead and flip on over to this first part here. We're going to go through some examples. I'm going to have you write these down with me. So for the first example, we are going to look at 18x to the 20 over 18x to the 20. So we've talked about this. If we have the same thing over the same thing, that is always going to give us 1 whole. No matter how complicated they get, that's 1 whole. All right, let's look at the next one. So on letter B, I have w to the 8th, z to the 15th over w to the 8th, z to the 8th. Okay, so again, I'm going to look for anything that's the same. Well, there's a w to the 8th over a w to the 8th. So anything over the same thing, cancel those out. Those become 1 whole. That would be no different than if I used subtraction and said 8 minus 8 is 0. W to the 0 would be 1 whole. Now I'm going to remember what we talked about in the other lessons, where if I have z to the 15th over z to the 8th, then I'm going to subtract. So 15 minus 8 is going to give me 7. So this would be z to the 7th. Okay, if I look at a third example, letter C, I'm going to put 9x to the 5th, y to the 12th, over 3x squared y to the 12th. All right, so if I look at this one, 12 minus 12 is 0. Anything to the 0 is going to be 1 whole, or it's the same thing over the same thing, so those will cancel out. I can go ahead and simplify 9 over 3. 9 over 3 simplifies to 3. And then now I can go ahead and subtract my exponents here. So 5 minus 2 would be x to the third. All right, 5x to the 0. So let's look at what 5x to the 0 would be. So kind of the rule that we're coming up with here is that anything to the 0 power is going to equal 1 whole. So just like on that first part that I just showed you, when we were looking at 2 to the 0 was 1, 10 to the 0 was 1. Okay, if I'm looking at this, 12 minus 12 is 0, so this is y to the 0. Y to the 0 is 1. So the rule is anything to the 0 power, anything to the 0 power equals 1. And that's very important. So, like I said over here, if I have 4 to the 0 power, that's 1. If I have a to the 0 power, that's 1. Anything to the 0 power is 1. All right, so if I look at this one right here, x to the 0 power is 1. So this is like saying 5 times 1, which is just 5. Okay, so if I go back up and look at the got it from the very beginning, it says negative 3.6 to the 0 power. Well, we just said anything to the 0 power is 1. So that answer is 1. Okay, all right, let's go ahead and go down to the second got it, and let's look at some examples for this one. All right, so letter A. We're going to use 2 to the 8th over 2 to the 11th. All right, and we're going to start back to what we talked about before. You always start with this number and subtract the second number. So what I'm going to do here is I'm going to say 2, and this is 8 minus 11. Okay, if you're not good at your negatives, you probably want a calculator, and you want to go ahead and do 8 minus 11, and 8 minus 11 is negative 3. So this is 2 to the negative 3. Okay, well when I'm working with exponents, I cannot have negative exponents. So now I'm going to show you what to do with those. So just like on the launch today, when I came up with negative exponents, it meant that it was really a fraction in disguise. Okay, notice that the 2 came down here as in the denominator. This was the negative 1, and it went to the denominator for the 10. So what I'm going to do is I call this moving it downstairs. So I have a fraction in disguise. I need to move this guy downstairs. So now this is going to be 1 over 2 to the positive 3 power, because now I made it into a fraction. And now I'm going to go ahead and do 2 times 2 times 2, which is 1 over 8. And that is my final answer. All right, let's look at another one. So B, 100 B to the 50 over 200 B to the 75. All right, so the first thing I would do is I'd go ahead and simplify my numbers. Okay, 10 will go into 100, but so will 100, and 100 will also go into 200. So basically I'm knocking off the zeros here, and I get 1 over 2, and I still have B to the 50, B to the 75. Because these have the same base, they both have B, I can subtract my exponent, so I'm going to do 50 minus 75, which is negative 25. Okay, so now I have 1B to the negative 25 over 2, just over 2. Okay, now I don't have to have that 1 there if I don't want to. All right, so here's where I say anything with a negative exponent is going to move downstairs. Okay, so here is my negative exponent. I'm going to move him downstairs so that my final answer, I'm going to leave the 1 over 2B to the positive 25. All I have to do is move it downstairs and it turns it into a positive. Alright, let's look at another example here and make sure I have enough space. Alright, letter C. We're going to say a to the negative 3, b to the 7th, c to the 5th. Okay, all over a to the 5th, b squared, c to the 7th. Remember, at any time if I'm going too fast, just pause the video until you can catch up. Alright, so you guys see that there's a bunch of A's and a bunch of B's and a bunch of C's. So we can use some subtraction, and we're going to have to be really careful here. So I'm going to start with this negative 3 minus 5. So think about what I just said. Negative 3 minus 5. Negative 3 minus 5, and if you don't know this, put it in your calculator, would be negative 8. So this right here is going to simplify to a to the negative 8. Okay, then I'm going to go to the b's. Well, the b one's pretty easy because you just have to subtract. So 7 minus 2 would be b to the 5th. Alright, and then I'm going to do the c's. So I'm going to do 5 minus 7. So think about it. 5 minus 7, if you don't know what that is, do it in your calculator, would be negative 2. So this is c to the negative 2. Okay, then I said anything with a negative exponent needs to move downstairs. So I'm going to create a downstairs for my denominator, and I'm only going to move negative exponents. So this one needs to move down, and this one needs to move downstairs. Okay, the b to the 5th is going to stay upstairs. Okay, so my final answer would be b to the 5th over a to the 8th, c squared. And that's my final answer. Okay, let's go ahead, and before we do one more of those examples, let's go ahead and try to do this got it before I get a little bit harder. Let's try to do this one. And I've kind of run myself out of space, so I think I'm going to go right there and do this one. Okay, so why don't you go ahead and try it first. So pause the video here, try it, and then unpause and watch how I do it. Alright, so hopefully you guys tried this one. Let's see if you got it right. So I'm going to start with the end. And this says 2 over 5. So I'm going to take 2 minus 5. So that would be m to the negative 3. And then I'm going to take n to the 4th, and that's n to the 3rd. So 4 minus 3 would be 1. So I just need to write an n. If you wrote an n with a little baby 1 there, that's fine, but it's not needed right there. Okay, the only thing I move downstairs is negative exponents. So this guy should be moving downstairs. So that my final answer is n over m to the positive 3. Okay? Alright, the last one I'm going to do then in this box is one that's a little bit harder. We're going to be distributing a negative this time. Alright, so here is letter D. We're going to do 2x to the 3rd, y to the negative 5, all to the negative 2. Okay, so here's what we're going to do. We're going to distribute that negative 2 just like we did earlier. So I'm going to give that negative 2 to the 2. I'm going to give it to x to the 3rd. And I'm going to give it to that negative 5 right there. So I'm going to write this out. 2 to the negative 2. Now remember, powers, 2 powers get multiplied. So 3 times negative 2 is a negative 6. So x to the negative 6. Powers, 2 powers get multiplied. Negative 5 times negative 2 is a positive 10. Alright, now we're going to remember the only things that move downstairs are negative exponents. So go ahead and find your negative exponents. That's this one and this one. Those two need to move downstairs, but Mr. Y the 10th, he's going to stay upstairs. Okay, so my final answer would be y